Graphing quadratic functions. The graph of any quadratic function is the U-shaped curve called a parabola. An example is graphed to the right over here. We can use the function to plot points and construct a graph. Typically, the x values will be provided. Sometimes we'll be given in words like from A to B. That is, for example, e.g. that means for example, from -2 to 2. It can also be written using symbols, such as a is less than or equal to x, which is less than or equal to b. For example, -2 is less than or equal to x, which is less than or equal to 2. To graph the function f of x equals ax squared plus bx plus c, Step 1. Draw a table for the x values provided. Step 2. Substitute x values into the equation to find matching y values. Step 3. Plot the points on a graph. And Step 4. Connect the dots with a smooth U-shaped curve. Example 1. Graph g of x is equal to x squared plus 2x minus 3 in the coordinate plane shown to the right, from -3 to 1. Here's our 4 steps again. Draw a table for the x values. Substitute the x values to find matching y values. 3. Plot the points. And finally, connect the dots. Answers on the next few slides. So our first step, draw the table for the x values. Now, we're going from -3 to 1. So here's -3, then we go -2, -1, 0, and 1. Now substitute the x values in the equation, right up here, to find the matching y values. So let's try -3 first. So -3 squared is 9, plus 2 times -3, so 2 times -3 is -6, minus 3, and 9 minus 6 minus 3 is 0. So I'm not going to do all of these, but I'll do the easy one here. When x is equal to 0, these terms go away, and we get -3. Step 3, plot the points. So let's look at this point again, -3, 0. That's over here. And then the other one we've calculated here, 0 and -3. That's 0, -3. And please check the others, but it should all work right. And finally, connect the dots, but use a smooth U-shaped curve. Don't draw straight lines between the points, but draw this curve here, which is a parabola. Example 2. Graph f of x is 2x squared minus 4x minus 3. That satisfies the inequality now. It's -1 is less than or equal to x, which is less than or equal to 3. Step 1. Draw the table for the x values. And we go from -1 to 3. So here's -1, 0, 1, 2, 3. Substitute the x values in to find the matching y values. So let's start with -1. So that's going to be 2 times -1 squared, which is 2, minus 4 times -1, well that will be plus 4, minus 3, and we get 3. Let's try 0. X squared goes out, x goes out, and we're left with -3. Let's do one more. Let's try number 1. So that's going to be 2 times 1, which is 2, minus 4, minus 3, and that will be -5. Plot the points now. So here's -1, 3. The next one, 0, -3. Then we have 1, -5. 2 is -3. And finally, 3 is 3. Finally, connect the dots with a U-shaped curve. Don't draw straight lines between the dots. And what do we have? We have a parabola. Graph g of x equal to -x squared plus 3x plus 1 in the coordinate plane shown to the right that satisfies the inequality -1 less than or equal to x less than or equal to 4. Draw a table for the x values provided. So we start at -1 and wind up with 4. So -1, 0, 1, 2, 3, 4. Substitute x values to find the matching y values. Now we have to be careful with this first term here. We're going to start with -1. So -1 squared is +1, but this negative changes that to a -1. -3, right? Plus 3 times -1, plus 1, And what do we get? We get minus 3. Put in 0, that's easy. These two go out, and we're just left with 1. Now put number 1 in. So we have 1 squared, which is 1, but we have that negative again. Negative 1 plus 3 plus 1, and we get the value of 3. Now let's look at 2, because it looks like we get the same value of y. Minus 2 squared, so that's going to be minus 4, plus 3 times 2, which is 6, plus 1. Yep, that gets us 3 also. And you can please feel free to check the last two numbers. Next, plot the points, and that's what we have over here in green. All of these points come from this table. And then connect the dots. This double 3 gives us a little issue right over here, because we can't have a flat line connecting them. You still have to have this curve that goes up a little bit and then comes back down. And once again, we have a parabola. And here's the explanation for that. The vertex, which is the top, is not at an integer value, but rather between x equals 1 and x equals 2. And that's what we drew on the last slide, because a parabola is not shaped like a curve and then a straight line and comes down. To find the vertex value, find the average or midpoint of the two x values. In this case, x is equal to 1.5, and substitute that into the function to find the corresponding y value. So when we plug in x is equal to 1.5 in the function, g of x here, we get g of x is 3.25. That means the vertex is at 1.5, 3.25.